Welcome to GBS 221, Chapter 4. Today we'll be looking at different ways that we can display and explore data. The first way is a dot plot. A dot plot is where we take a horizontal number line and we simply display each and every observation as a dot along that horizontal number line. For instance, let's say that I approached 5 different individuals and I asked them, how many letters are in your first name? The first individual, Joe, told me there were 3 letters in his name. The second, Sue, told me there were 3 letters in her name. Larry, Larry, told me there were 5 letters in his name. I had a person named Ed, 2 letters in their name. And last, a person named, I don't know, Bill. Bill had 4 letters in his name. So that's my raw data there across the top. All a dot plot would do would be to take a horizontal line and then indicate the frequency of occurrence, each of our observations, as a dot along that line. You'll see instances where there are multiple observations of the same value. We denote by having multiple dots. Okay, we had 1 observation, 2, 2 observations of 3, 1 observation with 4 letters, and 1 observation with 5 letters. Now, one of the benefits of using this type of display is that you don't lose the identity of any of the pieces of values. If you go back and look at the frequency distribution, although we group data according to some interval or class, the actual identity of each and every one of those those pieces of raw data was lost. I could tell you there were 5 observations that fell perhaps between 10 and 20, but not exactly what those observations were without the benefit of having that raw data in front of me as well. With a dot plot, we preserve the identity of each of those values so that if I had not given you that raw data, you could recreate it using this. If you could recreate it, you could find the mean, the median, the mode, the standard deviation, the range. In fact, straight from here, we could work that data, or we could list it back out in raw form and solve for all those things. With a frequency distribution, we could only do that based upon midpoints, and it would be an estimate. So again, one of the huge values of the dot plot is that the identity of each and every value is in fact preserved. The same is true of a stem and leaf display. A stem and leaf display instead looks at the data using a vertical line separating into 2 columns. One column is where we place the stem values. The other is where we place the leaf. Okay? Once again, this is beneficial in that we don't lose the identity of each and every observation, so we can go back and recreate the raw data to do with it what we'd like regarding finding, again, things like mean, median, mode, dispersion, range, and all of that. With a stem and leaf display, you're going to see that the leading digit or digits is placed to the left of the number line, and the trailing digits or digits to the right. Now, for our purposes in this course, we're always going to treat just the last digit as the lead. For instance, let's say that I was given the number 123. In that case, the 123, so 12 would be the stem, the leaf would be the 3. Okay. So I did give you an example with Janssen Motor Company where we have some observations developing a new engine to reduce gas consumption. The miles per gallon for 20 mid-sized cars with is provided create a stem and leaf display. I'm not certain why we have the A, B, C there, or if you have them on your slides, or just how it's focused on my phone here. But nonetheless, or my, I guess you should say, you see the observations 32, 20, 30, 39, 28, 21, 36, 20, so on and so forth. The largest number we see is 39. The smallest number we see is 18. You'll see that I have leading digits of 1, 2, and 3. Those 3 items will be my stems. 1, 2, and 3. Now my leaves, I'll go through all of the data and write the number that is the trailing digit. I want to put those in order from smallest to largest. Okay? Anytime something appears more than once, I want to write that leaf for each and every occurrence because, again, one of the benefits of the stem and leaf display is I don't lose the identity of the observations. I want to make sure multiple listings appear multiple times. The first one, a stem of 3, a leaf of 2. The second, a stem of 2, a leaf of 0. The third, a stem of 3, a leaf of 0. The fourth, a stem of 3, a leaf of 9. The next, a stem of 2, a leaf of 8. 21 is stem 2, leaf 1. 36 is stem 3, leaf 6. 20 is stem 2, leaf of 0. 18, a stem of 1, a leaf of 8. 32, a stem of 3 again, a leaf of 2. 37, stem 3, leaf 7. 29, stem 2, leaf 9. 30, got a stem of 3, a leaf of 0. 23, a stem of 2, a leaf of 3. 25, stem 2, leaf 5. 19, stem 1, leaf 9. 30, stem 3, leaf 0. And here is my finished product. You'll see that I put the numbers from smallest to largest. I had to go back and make space a couple of times. But now I could go back and I could recreate the data. I've got an 18, a 19, got a 20, 21, 23, 25, 28, 29. Pardon me, I have two 20s. I've got three 30s, two 32s, 36, 37, and a 39. So again, not given the raw data, I could go back and I could recreate it. The textbook has some nice pictures, better than mine, showing semi-linked displays, but I wanted to walk you through it at least a little bit before turning to the study assignment. The next thing that we'll discuss again in this chapter is dispersion. We talked about standard deviation, and it is the most widely used measure of dispersion, but this chapter is going to focus in on dividing data into parts. The parts we'll look at are quartiles, deciles, and percentiles. A quartile divides the data into 4 equal parts, 4 quarters, 25%, 50%, 75%, and 100%. Okay. Deciles divide the data by tens. A decile of 1 is 10. A decile of 2 is 20. A decile of 3 is 30. A decile of 9 is 90%. Percentiles divide the data just as you would imagine. A percentile of 67 would be a 67. We'll use the same formula for dividing quartiles, deciles, and percentiles. That formula is L sub P is equal to N plus 1 times the quantity P over 100, where N is the number of observations, and P is the percentile of interest. Now, if we're looking at quartiles, the first quartile is 25%. That would be the percentage of interest if we're looking for quartile 1. If we were looking for quartile 3, the percentage of interest would be 75%. Quartile 2, which is incidentally also the median, would be at 50%. So here's another method for finding that median. A decile of 3 would be a percentile of interest of 30%. Percentile of 82 would be a percentile of interest of 82. So we'll plug the N, the number of observations we're dealing with, there's pieces of raw data, in for N, the P for the percentage of interest, and you'll notice that's divided by 100. We're just simply expressing that percentage as a decimal. Okay? So when we're asked to find a quartile, a percentile, or a decile, we can apply any of them to this formula. Now what this is going to give us is the location of the data that is of interest to us, not the actual value. Okay? So to understand that further, let's look at the example I have here. The revenues of the top 11 personal computer manufacturers are given in 100 millions. Watch that on the homework. I had a couple of you that were not noticing the labels and had some trouble getting the correct solutions. Let me go ahead and recreate this raw data on my whiteboard. I am asked to find first the first quartile, next the third quartile, and then to determine the median. So we know we'll use the same